In this presentation, we'll explore the challenges in snack food production, where the impact of high temperature processes on bearing performance necessitates frequent maintenance. We'll show how an innovative technology from SKF can help to address this issue. Managing lubrication in these applications is challenging and can add considerable cost in terms of lubricant and labour. The limitations in grease technology for consistent performance at elevated temperatures often require frequent relubrication to ensure reliability. The associated planned downtime for these activities can mean that asset intensity potential is not fully achieved. Proactive food safety programs are becoming increasingly complex. Introduction to law of the Food Safety Modernization Act in the United States, for instance, requires full compliance in hazard analysis and critical control points. So, understanding areas where risk of lubricant leakage or catastrophic failure can be minimized can also help to protect brand image, reducing the risk of a product recall. In products where industrial fryers are used for production of potato chips or crisps, corn-based snacks and the like, paddles agitate the cooking oil. The paddle support bearings are in close proximity to the oil level and are constantly splashed by the oil. A typical issue arises when the oil at process temperature of 180 degrees Celsius, that's 356 degrees Fahrenheit, contacts the bearing seals. This can degrade the seal material, causing it to debond over a period of time. Regular cleaning of the asset is known as a boil out, where the oil is drained and the asset is filled with a boiling caustic solution for up to 7 hours. This can also have an adverse effect if the caustic solution enters the bearing. It washes the lubricating grease out, necessitating relubrication of the paddle support bearings prior to refilling the fryer with cooking oil and restarting production. This cycle can lead to a risk of the lubricants entering the process oil. We typically see the bearings in these paddle support applications being replaced every 3 months to be on the safe side, since experience shows that seal degradation and corrosion buildup can lead to catastrophic failure if left to operate for much longer. So our question when studying these applications was to ask, what if we could significantly reduce the risk of process oil contamination, extend the replacement interval of the paddle support bearings, and support compliance to the hazard analysis and critical control point procedure by revising the bearing's internal design, allowing the cooking oil to effectively lubricate the paddle support bearings. Our study of the application showed that the conditions were extreme high temperatures, but with low load and at low speed, so we could utilize a special fully crowned cage made of high temperature plastic. Now, this material can not only survive the extreme temperature, but it's also highly resistant to abrasion and can tolerate the low lubrication properties of the cooking oil. In conjunction with stainless steel inner and outer rings and using stainless steel balls, we improve the corrosion resistance in these environments. And by adding stainless steel outer shields instead of traditional rubber seals, we make sure that the cooking oil enters the bearing to lubricate, but prevent the possibility of process material getting into the bearing. The design also easily survives during the caustic boil-out operation until the next cooking operation where the cycle begins again. With this technology, you can run the paddle support bearings reliably for 16,000 hours, which is a significant step up in bearing life for these applications. By eliminating the need to relubricate after each caustic boil-out, you can avoid the process oil contamination with the bearing grease, even if it is food grade. and the use of stainless steel materials for the rings, balls and shields improves the corrosion resistance in the application, further supporting the extended life. Implementing this technology, which utilizes the process oil to lubricate the bearings, you'd then benefit by being able to decrease your maintenance and bearing replacement costs, and you'd also increase reliability and throughput potential by reducing unplanned stops due to bearing failure. And also, as mentioned before, a relubrication-free technology does support your proactive food safety programs. This is how one of our customers, a major snack food producer, benefited from the fryer bearings technology. Their operation ran 24 hours a day, 6 days a week, with a weekly caustic boil out. The traditional paddle support bearings were changed at the end of a 3-month period, based on past experience. This in order to reduce the risk of a catastrophic bearing failure that could lead to a product recall, which in many cases can have a considerable impact, not only in terms of direct cost, but also the often much higher cost of damage to the brand image. After installing the SKF fryer bearing technology, the bearing life has now been extended to 16,000 hours. The maintenance window after caustic boil out operation has been shortened, reducing maintenance costs and achieving a payback in just 8 months. Now, this technology has also helped them to remove the risk of process oil becoming contaminated by the traditional grease lubrication. SKF have now developed an extensive range of bearings for these applications, in both metric and imperial shaft sizes, to support the markets globally. The references given here are a representative example of the part numbers where individual bearings can be ordered. If required, complete units incorporating a cast stainless steel housing to complement the corrosion resistance needs are also available.